Hi, everyone. Hope you had a nice weekend, and also hope that you found some time just to go over that practice test that I uploaded. So like I said before, the practice test has exactly the same format as the test you're going to write on Wednesday. I've just changed the questions a bit. Okay, just to give you some more practice with those kinds of questions. Okay, so today we're going to go through that practice test today and tomorrow, just in case we run out of time. If you do have any questions while I'm going through it, please stop me right away so that I can, go through that particular question, just so that we can cover everything before Wednesday. Okay, and then on Wednesday morning at 10:30, so sorry, between 9:30 and 10:30, we won't be having a tutorial session, but I will be available on Zoom for any questions that you have. Yeah, and then from 10:30 to 12, you will be writing your test. Okay, it's the same procedure as your tutorial test. So the PDF will be available at 10:30. You go through it, write your test, scan everything, and then you can upload it using the submission there. Okay, so let's go through the practice test. So question 1. Okay, this was finding the area using the limits of a Riemann sum. So we know we've got these few things we have to do before the main calculation, and that is finding delta x. So that's going to be b minus a over n. So that's 0 minus 2 over n. So that's 2 over n. Okay, and then once we found that, we can find xr. That's going to be a plus r delta x. So in this case will be minus 2 plus 2i over n. And then the last bit of things we need to do is f of xr. Yep, that's going to be xr cubed minus 4xr. And then we can just substitute in the xr that we've just found. So this is going to be minus 2 plus 2i over n cubed minus 4, and then minus 2 plus 2i over n. Okay, so that's xr cubed minus 4xr. Okay, so we just need to expand this out and then simplify. Okay, so that will help us later on when we have to do the Riemann sum. So this is going to be minus 2 cubed plus 3 times minus 2 squared times 2i over n, and then plus 3 times minus 2 times 2i over n squared plus 2i over n cubed. So that handles the cubic part. And then for the other parts, we're going to have minus 4 times minus 2. That's going to be plus 8. And then minus 4 times 2i over n. That's minus 8i over n. Okay, so let's collect all the like terms together. So we're going to end up with minus 8 plus 24i over n minus 24r squared over n squared plus 8r cubed over n cubed. And then we have plus 8 minus 8i over n. Okay, so we've got two r terms that we need to group together. So this one and this one we need to group together. And we also have a minus 8 and a plus 8. So those can go away. Okay, so this now becomes, let's put the r cubed first. So that will be 8 over n cubed r cubed minus 24 over n squared r squared. And then plus 24 minus 8. So we're going to have plus 16 over n times r. Okay, so we've got our function now nicely written out. So that's going to help us a lot. Now we can find the area using the limit of the Riemann sum. So we have the limit as n goes to infinity, the sum from I equals 1 to n, f of xr delta x. Okay, it always starts off like that. Okay, this is going to be the limit as n goes to infinity, the sum from I equals 1 to n, f of xr, we just found that. That's going to be 8 over n cubed times r cubed minus 24 over n squared r squared plus 16 over n r. And then don't forget your delta x. That was 2 over n. So we need to multiply everything by 2 over n. Okay, good. Let's multiply this out and then separate our sums. So this will be the limit as n goes to infinity, the sum from I equals 1 to n, 2 times 8, so that's going to be 16 over n to the 4 r cubed minus 48 over n cubed r squared plus 32 over n squared r. Okay, so that's just multiplying our delta x inside. Okay, now we can separate our sums out. So this is going to be the limit as n goes to infinity, 16 over n to the 4, and then we have the sum of r cubed minus 48 over n cubed, and then we have the sum of r squared, and lastly 38 over n squared, and then we have the sum of r. Okay, so we've got this sum here, this sum, and this sum. Okay, remember, we don't want to work with summations. We'd rather work with the closed form expressions with n. So we're going to replace the summations with the expressions in terms of n. So let's do that. So this will be the limit as n goes to infinity, 16 over n to the 4. The sum of r cubed, we can replace that with n plus 1 over 2, all of that squared, minus 48 over n cubed. The sum of r squared, we can replace that with n times n plus 1 times 2n plus 1, all over 6. And lastly, the sum of I, we can replace with n times n plus 1, all over 2. Okay, are there any questions about this step? Okay, so everyone's okay with this step now. Okay, awesome. Let's simplify this now. So this will be the limit as n goes to infinity, 16 over n to the 4. Now we can square this out. So we're going to have n squared, and then n plus 1 squared will be n squared plus 2n plus 1, all over 4. Okay, so I've just squared all the terms out. Okay, then we have 48 over 6, so that's going to give us 8 over n squared, and then n plus 1 times 2n plus 1 will be 2n squared plus 3n plus 1. Lastly, 38 divided by 2, that's going to give us 16 over n, and then n plus 1. Okay, so I've just multiplied the brackets out so that we can now simplify things. Okay, one more thing that we can do. In the first term, we have n squared in the numerator, and we have n to the 4 in the denominator. We can cancel this n squared and change the bottom to an n squared. Yeah. And then 16 over 4, we can cancel the 4 here, and the 16 will now become a 4. So 16 over 4, that's 4. Okay, so let's multiply this out and see what we get. So we're going to get the limit as n goes to infinity. 4 over n squared times n squared, that's going to be 4. 4 over n squared times 2n, that's going to be 8 over n. And then 4 over n squared times 1, that's going to be 4 over n squared. Okay, now for the next one, we're going to have minus 8 over n squared times 2n squared. That's going to be minus 16. And then minus 8 over n squared times 3n. That's going to be minus 24 over n. And then minus 8 over n squared times 1. That's minus 8 over n squared. Okay, last term, 16 over n times n. That's going to be 16. And 16 over n times 1. That's going to be 16 over n. Okay, now just looking at this, we've got a minus 16 and we've got a plus 16. So they are going to cancel. And then all of the terms with an n in the bottom, they're going to go to 0 because we're taking the limit. So 8 over n, that goes to 0. 4 over n squared, that goes to 0. Minus 24 over n, that one goes to 0. Minus 8 over n squared, that goes to 0. And lastly, 16 over n, that goes to 0. So everything goes to 0 except the first term. So our answer is 4. Okay. Are there any questions about limits of Riemann sums? Okay, so remember, this practice test is exactly the same format as your real test on Wednesday, which means the first question is going to be something like this. Okay, so please remember your definition of the Riemann sum, this over here. And please remember your substitutions. So your sum of r cubed, sum of r squared, and sum of r, you need to know those as well. Okay, any questions before we move on? Can you do another example? Okay, sure. Okay, so let's just call this example 2 on Riemann integrals. Okay, so this is not part of the practice test now. This is an extra example I'm just making up. Okay, so let's say we have f of x is equal to x squared plus 1. We want to find the area underneath 0, 1. Okay, so the first thing we need to do is find delta x. So delta x is going to be b minus a over n. So that's going to be 1 over n. Okay, xr is going to be a plus r delta x. So that's going to be 0 plus I over n. So that's just I over n. And lastly, f of xr is going to be xr squared plus 1. So that's going to be r squared over n plus 1. Okay, so we got all the pieces now for the Riemann integral. So the Riemann integral, or the limit of the Riemann sum, same thing. It's the limit as n goes to infinity, the sum from I equals 1 to n. F of xr delta x. Okay, so let's plug in what we know. This is going to be the limit as n goes to infinity, the sum from I equals 1 to n. F of xr is r squared over n plus 1. We calculated that above. And delta x is 1 over n. Okay, so that's going to be times 1 over n. Okay, so let's multiply that inside. So that's going to be the limit as n goes to infinity, the sum from I equals 1 to n, r squared over n squared plus 1 over n. Okay, so now we need to separate out the sum. So this is going to be the limit as n goes to infinity, 1 over n squared times the sum from I equals 1 to n of r squared plus 1 over n, the sum from I equals 1 to n of 1. Okay, so we've got this summation and this summation. We need to replace it with those expressions in terms of n. So let's do that. So this is going to be the limit as n goes to infinity, 1 over n squared. The sum of r squared, we can replace that with n plus 1, 2n plus 1, all over 6. And the sum of 1, that's going to be 1 over n times n. Okay, because 1 plus 1 plus 1 plus 1 up to n, that's just going to be n. Okay, so let's simplify this out. So we're going to have the limit as n goes to infinity. N over n squared is going to be 1 over 6n. And then n plus 1 times 2n plus 1 is going to be 2n squared plus 3n plus 1. And then n divided by n, that's just going to be 1. Okay, so let's, okay, so this is going to be the limit as n goes to infinity. Sorry, did I make a mistake somewhere here? Oh, sorry, that's n squared. Sorry, I forgot the square here. N cubed, n cubed. Sorry, I forgot there's an extra n at the bottom. Okay, so that's an n squared. Okay, so this is going to be 2n squared over 6n squared plus 3n over 6n squared plus 1 over 6n squared plus 1. So this is going to be the limit as n goes to infinity. This is going to be 1/3 plus 1 over 2n plus 1 over 6n squared plus 1. Okay, now again, all the terms with n in the bottom, they are going to go to 0. So we are left with 1 plus 1/3 or 4 over 3. Okay, exactly the same procedure as we did before. Okay. Any questions on this one? Okay, let's carry on with the practice test. So we're on question 2 now. Okay, so this was finding the derivatives of functions using FTC part 1. Okay, so 2.1. We're given f of x is equal to the integral from 0 to 3x plus 1, 1 plus t, all of that squared, dt. Okay. So we want to find f prime. That's going to be d by dx of the integral from 0 to 3x plus 1, 1 plus t, 1 plus t, all of that squared, dt. Okay, so we've got a problem here because the upper bound is a function of x. We don't want that. So we're going to let u be equal to 3x plus 1. And so du by dx is going to be 3. So this becomes d by du, the integral from 0 to u, 1 plus t, all of that squared dt. And then by the chain rule, we have du by dx. Okay, so now d by du of this integral. Remember FTC part 1, the derivative and the integral cancel. And we're just left with 1 plus u, all of that squared. And then du by dx, that's going to be 3. Now we can't leave it like this. We need to put our u expression back. So this will be 3, and u is 3x plus 1. So it will be 3x plus 2, all of that squared. Okay. Any questions on this one? Okay, so please take a look at the working out that I've used for this one. I know some of you used a different method from that chemistry tutor. That's fine, but please make sure that you show all your working with all the steps. I noticed in tutorial test 1, a lot of you were skipping out steps or not writing it out properly. Okay, so please make sure that you do it, that you show all your working for the test coming up. Okay, let's take a look at the next one, 2.2. Okay, so now we have f of x is equal to the integral from x to x squared plus 1. Sorry, let's rewrite that. X to x squared plus 1. And then we had tan of t dt. Okay, so since the lower bound and the upper bound are functions of x, we need to split this up into 2 parts. So this is going to be f of x is equal to the integral from x to some constant. Doesn't matter what the constant is. So let's just say it's 0. And then it's going to be tan of t dt plus the integral from the same constant to the upper bound, tan of t dt. Okay, so now for the first term, we've got x in the lower bound. We want it in the upper bound. So we can swap the bounds, but remember we have to put a minus sign. So f of x is going to be equal to minus the integral from 0 to x, tan of t dt, plus the integral from 0 to x squared plus 1, tan of t dt. Okay, so we've just written it in a different way to make it easier to use FTC part 1. So now we want f prime. So f prime of x will be minus d by dx, the integral from 0 to x, tan of t dt, plus d by dx, the integral from 0 to x squared plus 1, tan of t dt. Okay, so for the first term, we don't have any problems because the upper bound is just x. For the second term, we do have a problem because the upper bound is a function of x. So we're going to have to say u is equal to x squared plus 1. Okay, so if u is equal to x squared plus 1, then du by dx is going to be 2x. Okay, so let's now apply FTC part 1. So we're going to have f prime of x is equal to minus the derivative of the integral. We know that it cancels out. So we have minus tan of x plus. Now the red term is going to be d by du, the integral from 0 to u, tan of t dt. And don't forget the chain rule. We need du by dx. So f prime of x is going to be minus tan of x plus tan of u times 2x. Okay, but we don't want tan of u. We need to put the x expression back. So this is going to be f prime of x is equal to minus tan of x plus 2x times tan of x squared plus 1. Okay, are there any questions about this one? Okay, so you'll get something similar to these two in your test. Okay, any questions before we move on? Okay, let's take a look at question 3. Yes, you got a question?
Question, sir.
All right, yeah, what's your question?
My question says from the second step, why you put negative there?
Oh, from here. So if you have the integral from a to b, f of x dx, if you want to swap the bounds, so here we have from a to b, if you swap the bounds, you pick up a minus sign. So this is minus the integral from b to a, f of x dx.
Okay, thanks.
Cool, no problem. Okay, any other questions from anyone else? Okay, let's go on to the next question. So question 3. Okay, so these were the definite integrals. So question 3 for your test will be on definite integrals. So we have the integral from -2 to 2 of x to the 4 minus 3x squared plus 3x minus 1 dx. Okay, so this is going to be the antiderivative of x to the 4 is going to be 1/5 x to the 5. Antiderivative of minus 3x squared is going to be x cubed. Antiderivative of 3x is going to be 3/2x squared. And the antiderivative of -1, that's just minus x. Okay, and we need to evaluate this from -2 to 2. So this is going to be 1/5 of 2 to the 5 minus 2 to the 3 plus 3/2, 2 squared minus 2. So that's evaluating at the upper bound minus, we now evaluate at the lower bound. So it's going to be 1/5 minus 2 to the 5 minus -2 cubed plus 3/2 minus 2 squared minus -2. I've got another question here. Please go back to the previous example. Sure, let's have a look here. Okay, here we go. Where's your problem?
Sorry, sir. I want to ask why you said that 2 times.
This 2.
Yes, sir.
That's from the du by dx. So we've got the 2x over here. So then I'll put that in the front.
Not
Yes.
this one, sir.
Okay, from the chain rule. Okay, you got it.
No, sir, not that one. From the top one. Top one.
Top over here.
Yes. Yes, when you get minus and plus, why you say?
Because I'm using FTC part 1. So remember for FTC part 1, we have d by dx, the integral from a to x, f of t dt. So if we're using FTC part 1, we need a constant at the bottom. Constant at the bottom, and we need x at the top. So we've got x at the top and a constant at the bottom. Over here, we've got x at the bottom, and we have a function of x at the top. So we can't use FTC part 1. So what we need to do is split up the integral into 2 parts. So the lower bound is with the first integral, and then we add the second integral, but with the upper bound. So you see we've got this constant here and the constant here. So now we can use FTC part 1. So we needed to split it up like that. So we can do FTC part 1 on the first integral and FTC part 1 on the second integral.
Yes, thank you.
Okay, sure. Yeah, so we can't do it on this first thing. We need to split it up first. Okay, so let's take a look here. So now we just need to simplify this. So 2 to the 5 over 5, that's going to be 32 over 5. Then minus 2 cubed, that's minus 8. 3 over 2 times 2 squared, that's going to be plus 6, and then minus 2. And then for the second part, we're going to have minus 32 over 5, plus 8, plus 6, and then plus 2. Okay, so this is going to give us 32 over 5 plus 32 over 5. So that's 64 over 5. And then minus 8 minus 8, so that's minus 16. Plus 6 minus 6, that's going to give us 0. And then minus 2 minus 2, that's going to be minus 4. Okay, so we're going to get 64 over 5 minus 20. Or we can write this as 64 over 5 minus 100 over 5. So we're going to end up with minus 36 over 5. Okay. Okay, any questions on this one? Okay, so nice and easy. Let's take a look at the next one. 3.2. So here we have the integral from 1 to 5 of 1 plus x over the square root of x cubed dx. So remember, we like to work with powers. So let's change the root into a power. So this will be the integral from 1 to 5, 1 plus x, and then the square root of x cubed is going to be x to the minus 3 over 2. Okay, because it's in the denominator. So when we take it up to the numerator, we get the minus sign, dx. So this will be the integral from 1 to 5 of x to the minus 3 over 2 plus x to the minus 1/2 dx. Okay, so let's integrate. So we add 1 to the exponent to make it minus 1/2. Divide by minus 1/2, that's the same thing as multiplying by minus 2. And then for the next one, we add 1 to the exponent to make it 1/2. Divide by 1/2, that's the same thing as multiplying by 2. And then we have x to the 1/2. Okay, going from 1 to 5. Okay, so let's substitute. We're going to have minus 2 over root 5 plus 2 root 5 minus, then we're going to have minus 2 plus 2. Okay, so then we end up with minus 2 over root 5 plus 2 root 5. Okay, but if you wanted to, we can simplify this some more. So this is going to be minus 2 root 5 over 5. We just times top and bottom by root 5. Same thing with the other one, but timesing by 5, we get 10 root 5 over 5. And then this gives us 8 root 5 over 5. Okay, any questions on this one? Okay, let's just do the last one for question 3, and then we can do the rest tomorrow. So 3.3, we have the integral from 0 to pi of 3x cos of x squared dx. Okay, so this is going to be a u substitution because we have cos of x squared. So u is x squared, du is going to be 2x dx. But if we look at the question here, we've got 3x dx. Over here, we've got 2x dx. That's not going to work. So we just do a bit of algebra. So 1/2 du is x dx. So 3/2 du is going to be 3x dx. And that's what we want. Now, if we change the bounds, if x is equal to 0, then the new lower bound is also going to be 0. And if x is equal to pi, then the new upper bound is going to be pi squared. Okay, so let's do the integral. So this will be the integral from 0 to pi squared. Cos of x squared becomes cos of u. And 3x dx becomes 3/2 du. So that's going to be 3/2. The integral from 0 to pi squared cos of u du. The integral of cos is going to be sine. So it's 3/2 sine of u from 0 to pi squared. So this just gives us 3/2 sine of pi squared. Okay. Because sine of 0 is 0, so we don't need to include that. Okay. Are there any questions on this u substitution? Okay, so that's going to be it for today. We will do question 4 and question 5 tomorrow. Okay, I see 2 people raised their hands. We only have 1 minute left before the meeting gets cut off. So please, can you post your questions on the WhatsApp group, or you can send it to me through email? Okay, because we're going to be cut off soon. Okay. Same for everyone else. If you have any questions about what we did today, please post them on the WhatsApp group or send me an email. Okay, and we'll finish everything off tomorrow. Okay. Yeah. Bye, everyone. I'll see you tomorrow for the remainder of the revision. Okay.
Bye, sir.
Everyone.